All right, we're at 27. This is the third video. Maybe I'll get to a fourth video. No, I hope this is it. You're given the derivative. Can you do the antiderivative? The approach is, where does the hook come from? And then understand that and work from there. So for an exponential, it comes from the exponent. The derivative is 2x. It was a 1. It became a 2. That's the fraction. And then we can ignore or release the hook. And then the rule for E is copy it. Plus C. Number 28. Again, press pause. Do your best first. And then press play. So the antiderivative here, again, where does the hook come from? What am I going to look at? And so for this, I'm going to write this calculus friendly. So in order to put it in the numerator, I got to multiply it by this, all of this by -1. So it'll be negative t squared plus t when I multiply it by -1. And I still have 2t minus 1 here. So now it's written calculus friendly. The hook should be negative 2t plus 1. If you look carefully, the difference between here is -1. So if I multiplied it by -1, they would match. And so the answer is negative e to the negative t squared plus t plus c. Done. All right, number 29. Again, I'm ready to go. Press pause and write it down and try your best first. So I recognize the hook is 1 over x, and I see 1 over x, so I rewrite it. So the hook, the derivative of ln x is there. And then I add, oops, what am I doing? I add 1 to the exponent and divide, or the reciprocal, and then plug in. And there you go. Number 30. Press pause and write it down. So the hook comes from the exponent. The derivative of negative x is negative, so we need a negative in front. So the rule is you copy it and then divide by ln of the base when the base is not e. That goes from 0 to 1. And then I'm just going to plug in 1, subtract, plug in 0. And you have the answer. That's really 1 over ln 3, or that's perfect the way it looks. Number 31. Oh, I wrote it down already. All right. So if I take the derivative, I get 2t minus 4. It's not going to match. Where is it? It will match. 2t minus 4. So if I multiply it times like 1/2 times 2 and 1/2, it matches, right? It's a logarithm. I was going to separate it into, a and b and so on, but hey, you should do the easy way first, right? So now the derivative on the bottom matches the top with 1/2 in front. 32. So I know this is not a logarithm. I see a square root. It's negative. This is going to be arc sine. But I got to rewrite it. So I'm going to factor out a negative Well, let's rearrange this first. So I'm going to put 12 in front. And then factor out a negative, so it's t squared minus 4t. So I factored out a negative for each. I put the 12 in front. It's going to be in the form of arc sine this way. To know what number completes the square, I take that b value and I divide by 2 and square it. So that gives me 4. So 4 completes the square. So if I distribute, I get negative 4. So because of that, I have to add 4 to keep it the same. So you have negative 4. I need a plus 4, so it's 0, so it matches. So 12 plus 4 is 16 minus, and then complete the square. So factor it, and it's t subtract 2 squared. A is the square root of t minus 2 squared, which is t minus 2. Sorry, that's u. Du is the derivative, which is 1, which is great. That's what I got. And then A is the square root of 16, which is 4. So the formula is going to be arc sine u over A plus C. Number 33. What we don't practice, we're going to forget. What interest rate would be required for a savings account to triple? So you have A equals P times e to the RT. When I divide by P, A divided by P, if I'm tripling, that answer is going to be 3. And it says what interest rate? So I'm looking for R, and it's 20 is the year. Type that in your calculator, just solve that equation, and it's 0.0549. Or 5.49%. So again, you press menu, algebra solve, and you just solve for R. 34. A population of, this is a logistic equation. Remember those? Now, this is kind of awkward looking. I'm going to change the way it looks because I need that C value. So e to the 4.8 is actually what C equals. So if you think of the formula, which is m over 1 plus C, this is the C value, and that's the K times M value. It says find the K value. So we know that negative K times M is negative 0.7. So K times M, and M is the numerator, is 0.7. Divide by 1,000. So we're going to move the decimal 4 to the left. So 3 to the left. So K is equal to 0.0007. B, what is the carrying capacity? M is the numerator. D, what's the initial number of rabbits? So to know what the initial number of rabbits were, it's when t equals 0. So if you plug in 0, you're left with 1,000 over 1 plus that. Just use your calculator, and you have to round. So it's about 8 rabbits. When you plug in 0 for t, you need a calculator, just plug it in. D, and it says the time at which the population is growing the fastest. So halfway there, so you make it equal to 500. Again, you're going to use your calculator and solve. So use your calculator, type it all in, comma T, and solve it. And if you did it correct, it's about 6.857 months. It'll be halfway there, growing the fastest. All right, 35. Another logistic equation. A wild preserve can support no more than 250 gorillas. 28 gorillas were known to be in the reserve in 1970. And then it gave us this. Find a formula for the population. So for the population, I need to know what K equals, which is 0.004. I need to know the carrying capacity, which is 250. And so the formula goes the carrying capacity over 1 plus C times E negative, and I need to multiply these together. So 4 times 250 is 1,000. And move the decimal. So what would that be? Is that just 0.1? Point 0.0004 0.1, right? Yeah, 0.1. So if I multiply k times m together, I get 0.1 and it's negative. There it is. It says when t is 0, the population at the beginning of 1970 was how many gorillas? 28. So if I put in 0 for t, basically what's 250 divided by 28? And then subtract 1. So about 8, 7.929. That's what c equals. So I divided those numbers and then subtracted 1. So the equation would look like this. And there's the equation to describe the growth of the gorillas. When will the population reach 249? That's 1 less than the capacity. So make it equal to 249. Use your calculator, press pause, and solve it. And the answer is in about 76 years. That's when, and that's very close to it. That's the maximum capacity. And in that year, does it say what year? When? That's fine. It'd be 2046. All right, 36. In 36, you have the derivative minus 2y equals x times y. So to get the derivative by itself, I'm going to add 2y to the right side. And then plug in. So plug in 0 for x and 2 for y and then get answers. So that's going to be 4. That's going to be 0. That's negative 1 plus 2. That's negative 4 plus 2. E. So if y is 0, then the slope is 0, no matter what the value is for the x coordinate when you plug it in. Then it says sketch it on your own piece of paper just for quadrant number 2. All right. How many goes up? 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2. So when y is 0, the slope is 0. Oh, shoot. When y is 0. These aren't when y is 0. And then put the point. So like at 0, 2, it was 4. At negative 2, 0, it's 0. At negative 1, 1, it's 1. At negative 4, 1, it's negative 2. and then we need to start filling it in. So this is 0 and 3. So that's 6. And then 0 and 4, that's 8. This is -1 and 2. That's -2 and 4, that's 2. This is -1. You know what I'm going to do? I'm going to factor out the y to make it easier to handle. So if I factor out the y and look at that, it's easier for me to calculate it. Okay, so -1 and 3. So -1 and 3, that's 3. -1 and 4, that's 4. -2, anywhere x is -2, this will all be 0. That's good to know. -3 and 1, that's going to be -1, -2, -3, -4. And then these on this side is going to match, right? Up there, like that. It says draw a solution curve through 0, 2. So you can see what direction it's going to go. This way. Then it's going to come down, and then it's going to come up. Turn and go up. And that's what the solution curve is going to look like. Then it says use Euler's method with the same starting point, and the change in x is -1/3. So let's do a little chart here to organize this. So we have the x, the y, the slope, and then it's the slope times the change in x, which is -1/3. We're going to start at the point with the totals, which is at 0, 2. So if you plug in 0 and 2, the answer is 4. And then if you go 4 times -1/3, it's -4/3. So count down. So this is -1/3. 2 take away 4/3 is +2/3. Compute this. You can use your calculator. It's 10/9. And then 10/9 times -1/3 is -10/7, 27. I want to get to -1. We're almost there. Take this number to this number. Get common. Go 9 times 9, right? So it's 18. Take away 10. 8/27. Plug in -2/3 and 8/27 into this formula, and you get 32/81. So you take 32/81 times -1/3, and you get -32/243. So this number times this number. And then now we're at -1, so we need to add these two numbers together, and you get 40/243. You can use your calculator. So this number and this number, you get 40/243. So using Euler's method, Bueller, using Euler's method, that would be the approximation. All right, number 40. Solve the diffie-q and find the particular solution to that. So we have y prime equaling, what did I already say? It was, when I factored out a y, it was x plus 2, right? What I said? Yeah. All right. So how do I do this? dy by dx. Separate the variables, so multiply by dx and divide by y. Integrate. This is going to be a logarithm. Press pause, right? You can do this. So now you've integrated it. To get y by itself, e. To remove the bars, we're going to go plus or minus e to the c and change it to c2. and then plug in the point, and the point was 0, 2, right? So plug in 0 for x, so y is going to be 2. Done. Perfect. Oh, there's an x. Done. All right, number 41. That's it, right? Does it? Oh, it continues on the next page. What? Okay, find the exact value of y at -1. That means you plug it into this equation. Remember, this is all in the exponent, so the answer is approximately 0.446. Turn the page. Yes, there's more. 42. Let R be the region enclosed by the graphs y equals cosine x cubed and y equals x squared. Set up and evaluate integral that gives the area. Show the equation used. Make sure your calculator is in radian mode. All right, so this is using your calculator time. It is in radians, RAD. If it's not in radians, go to the document, go to settings, it's number 7. Go to document settings, number 2. And then change that angle to radians and then press enter. All right, we're going to graph it. If you have something there like I do, you're just going to erase it. The first one is going to be what it says, which is cosine. So press the trig button, cosine x cubed. There it is. The second one is going to be y equals x squared. And so I get the part, let's zoom in on that middle part. So I'm going to change the window to 2's. So -2, 2, -2, 2. Now you can see it, right? So you can see the blue is on top, which is cosine x cubed, and then it starts to oscillate really fast, and then x squares right. So first I want to know what's on top and what's on the bottom. So start there. So to integrate, it's cosine x cubed minus x squared. That's top subtract bottom. Next, I need to know the bounds. So we're going to use your calculator for that. So press menu, analyze, and point of intersection, which is 4. And this is the lower oh, there it is. I was trying to think, where is it? Oops, let me try this again. I didn't see where it was. Menu, analyze, intersection. I didn't see that. There it is. I was looking for this. Move it to the left, press enter, and then move it to the right, and then as soon as it crosses over, it'll tell you what that point is. So it's negative 0.881. Negative 0.881. And it is symmetric, so on the other side is 0.881, the way trigonometry works. And then we want to find the area there using our calculator. So menu, analyze, and bounded area, which is 8. The left bound, I'm going to type in, see if it'll cling right there. So negative 0.880,696,1399. And then we're going to move over. And then the upper bound, we're going to type in 2. So it's 0.888 0.06961399. And then the answer is right there, which is 1.248249. Right there's the answer. Right there's the bounded area. It's good practice with your calculator. And that's the area I'm looking for. And you can see it shaded right on, so it's a nice pretty picture. 1.248 is perfect. All right, so we used our calculator, and then used our calculator and got the answer, but showed our work, right? And then the answer. 43. A particle moves along this, the velocity, at any time. That's the velocity. Find the total distance traveled from 0 to 2. So for that, we're going to integrate from 0 to 2. It's the absolute value of the velocity. And so I'm just going to plug that in with my calculator. And that's the answer. So you're integrating from 0 to 2, absolute value ln t plus 1 minus 2t plus 1. And then that should be the answer. That's the total distance. The other word is displacement. In that you would integrate without the absolute value bars. All right, last one, integrate. If I take the derivative, it doesn't match the top. I'm going to have to factor this. That's a difference of squares. And then one's going to be A, and one's going to be B. Again, press pause, see if you can find A and B before I do it. So A, I'm going to multiply it by 3 plus x. B, I'm going to multiply it by 3 subtract x. And that's equal to 3 minus 3x, the numerator. So if x equals negative 3, then I get 6b. Negative times a negative is 12. Divide, and b is equal to 2. We're going to let x equal positive 3. That's 6a. That's 0. 3 times 3 is 9. So that's negative 6. So divide, and a is equal to negative 1. Come back to the question here. And so a, we'll start there. That's negative 1 over 3 minus x. Now b is 2. Over 3 plus x. And the reason I didn't put the negative 1 in front, the derivative of negative x is negative 1, so it matches. These are logarithms. And that's it. You did it. Mr. G Math, over and out. I'm so proud of you. 3. And you did it. All right, till next time.